Hello team, in this lesson we'll talk about deadlocks and livelocks. At the beginning of the lesson I will explain you what a deadlock is and what livelock is. On the real examples we will reproduce with you such states and you will understand what to do to avoid states of deadlock and livelock. Let's start. Let's understand first what a deadlock is. The definition is simple. Deadlock is a state where two or more threads are blocked forever, waiting for each other. How it may happen? This situation may happen when two or more threads require the same locks but obtain them in different order. And to be honest, it is really hard to fall into the trap of deadlock nowadays, because modern tools for working with multithreading provide us with API to try acquire lock within the specific time and proceed execution in case lock is not acquired. I will explain such concepts in the next lessons. But you need to understand deadlock case so that you would understand the motivation to use other tools and classes that we are going to learn in the following lessons. You may have deadlock state in your app when you use synchronized methods or synchronized blocks. Let's review the next theoretical example. Imagine that you have two threads, and you have two locks. Thread number 1 captured the first lock and tries to acquire the second lock, but at this moment thread number 2 already got the second lock and tries to get the first lock. And here is a deadlock. Thread number 1 will never get the second lock. Why? Because thread number 2 holds the second lock and will not release it until it would get the first lock. But you already know that the first lock is not released by thread number 1 until thread number 1 will get the second lock. And here is the case when two threads are waiting for lock that is acquired by another thread. How to solve this theoretical example and avoid a deadlock? There are actually a few options here. The first and the easiest one, avoid acquiring multiple locks by a thread. In case threads need to acquire multiple locks, there are next options. The second option is to make sure you follow this rule. Always request locks in the same order in all threads. For example, if only we requested the first lock by thread number 1 and the first lock by thread number 2, we wouldn't be in deadlock state. And another solution is to use time restrictions to limit time of lock acquiring. For example, in case thread didn't obtain lock within the specific time, thread keeps execution. In this case, thread is not blocked for infinite amount of time in case it is unable to acquire a lock. Hope that now it is clear for you what a deadlock is and how theoretically to avoid it. Let's now look at code examples. We'll reproduce deadlock state and we'll fix it. I have deadlock issue demo class. You can find the source code of all examples in attachments to this lesson. I declared two fields here. I called them lock1 and lock2. I will use these objects for synchronization. In main method I declare two threads and instantly start them. In the first thread I capture lock number 1 and imitate some time-consuming operation by making my thread sleep for half of the second. Instead of this sleep operation could be any other time-consuming operation. After that, I try to capture lock number 2, but in this example we will never enter this block, and thread will be waiting to capture monitor of the lock number 2 object, because the monitor of the second lock will never be released. Let me explain why. So this thread is started and I create a new thread. In this new thread I capture second lock and after that I try to capture lock number 1. But I can't, because it is still captured by the first thread. And the first thread can't capture lock number 2 because it won't be released until the second thread will release the lock. And that's how we get to the deadlock state. Let's run this program. And you can see that I printed information about capturing lock objects, and JVM is working. It is actually does nothing at the moment because two threads just waiting until locks will be released, but we understand that they won't be released. Let's now try to fix this. So the first fix is not to use multiple locks in one thread. That is the easiest one, and I believe I even don't need to demo this. Just remove the second synchronized block and that's it. The second fix is to capture locks in the same order. I open Deadlock Solution Demo class. This is a similar example with only a few changes. In the second thread, we'll capture lock 1 first and after that we'll capture second lock. Let me run the program. And you can see that all lines of code are executed because in this case we don't have deadlock. And the third fix is to use timed lock attempts. But we'll learn how to use lock API in other lessons dedicated to lock API. So that's it. Now you know what a deadlock state is and how to avoid it. Let's now learn what a livelock is. Another issue that might appear during the execution of multithreading program is a livelock state. What is it? Livelock is similar to the deadlock in terms of the end result. Program will not produce any useful output, but different in terms of the root cause and actual state of the program. In livelock, two or more threads keep on transferring states between each other, instead of just waiting like we saw in deadlock example. In case of livelock, threads are not blocked actually. They are just too busy responding to each other to resume work. This is comparable to two people attempting to pass each other in a corridor. So imagine that you're faced with a friend of yours in a corridor, and you decided to move left to let your friend pass you. But your friend is also polite, and he decided to move right to let you pass. But you blocked each other again. Now you decide to move right, but friend of yours thinks that he is also responsible for what happened, and he decided to move left this time, and both of you are blocked again in corridor, and so on. How to avoid livelock? To avoid livelock, we need to investigate the condition that causes livelock state to come up with solution accordingly. So it is no universal solution to address livelock issue. A thread should stop repeating the same actions if no progress has been detected. And real-life scenarios may be very different case by case. Let me show you livelock example. We'll reproduce livelock state and we'll fix it. I open livelock issue demo class. We'll imitate family dinner. Imagine that we have one spoon and two spouses, wife Nastya and husband Igor. They are going to have a dinner, but they have only one spoon. By default, husband captured the spoon. And after that I run two threads. One thread for husband, where I call eatWith method, and I pass spoon and spouse. And the similar thread with calling the same method for wife. Here is the class of the spoon. It has owner, getter, setter, and use method. Setter and use methods are synchronized. When use method is called, I print the name of the spoon owner to indicate who used the spoon. And here is the spouse class. It has two properties, name and isHungry flag. By default, isHungry property is true. Let's look at eatWith method. This is exactly the method that we are executing in our two threads. I have loop here that checks whether spouse is hungry, and if yes, then I check whether the spouse owning the spoon at this moment. If no, I just wait for 1 second and go to the next iteration in a loop. During this 1 second, I expect my spouse would eat and will give me the spoon. But this logic will bring us to the state when two spouses constantly changing the owner of the spoon. When spouse is an owner of a spoon, I verify whether my spouse is hungry. Pay attention, I pass the reference to my spouse in the method eatWith. That's why I have the reference to object of other spouse and I can verify its state. And as you remember, all spouses are hungry by default. That's why I enter this if block and we changing owner of a spoon. Because each spouse is worrying about another one, and once spoon is passed to a spouse, I jump to another iteration of this loop. Let's run the app and see what we have. And as we can see in console, the threads are not blocked. They are working, but they are constantly passing the spoon to each other without eating at all. Because I call use method on a spoon only after that last if block, and my app never reaches this point in neither of the threads. How to solve this? I stop the app first and start thinking. Let's analyze how to solve this case. Actually, there are different ways to solve this issue, and only one of them is to limit number of passing spoon between spouses. For example, if Igor passed spoon to Nastya once and she returned it back, that means Igor may eat. The same rule applies for Nastya too. I open livelock solution file where I resolved the issue. To solve it, I introduce two more fields in spouse's type. The first one is spoon yield times. This number of times we pass the spoon to the spouse and let he or she eat first. The next new int field is spoon yield limit. This variable will store the limit number of passing spoon to a spouse. I initialize this field with 1. This means that in case I already passed my spoon at least once in the past, I'm not passing it to another spouse again. I increment spoon yield times when I'm changing owner of a spoon. And before changing owner of the spoon, I also verify whether I passed the spoon to a spouse previously in past or no. In this case, each spouse can pass the spoon only once, and after that, he or she will start use the spoon to eat. Let's check this. I run the program. In console, we can see that Igor suggested Nastya to eat, but Nastya refused and suggested Igor to eat. This time, Igor didn't play this game of polite husband and he started to eat. In console, we indicated that Igor has eaten. After that, we told Nastya that Igor is stuffed and is not hungry anymore. And after that, Nastya has eaten. Pay attention that this time JVM is stopped and we don't have livelock. Is that clear? Great! Now let's review what we have learned in this lesson. In this lesson we learned what a deadlock is and what a livelock is. We reproduced with you deadlock and livelock on code examples. After this lesson you know how to avoid deadlock and how to avoid livelock. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.